Yeah.
Okay, I think the stream is live.
Nice. Welcome back, everybody. See, I'll open up the stream so I can see the chat. Quickly mute everything because otherwise we'll get a massive echo. And here we go.
Ready?
Yes.
Okay. Well, then I would say let's start with taking a quick look at today's chapter release. So today we have the chapter number 4, it is, right? If you count
Number
the
4.
introduction.
Yeah.
And it's about layout. And let me see, I have the PDF here, so let me quickly open that and get it on screen sharing. So that should be this window. Yeah, I think that's correct. Okay, so this is the layout chapter that we got out today. And it's a long chapter. And in a way, it's a boring chapter, right? So, because it's kind of because of at least for editing it was after a while quite boring because, well, basically it's and in the beginning we describe the algorithm, right? We have these diagrams that go through all the steps that the layout algorithm takes, so that you can really trace that for yourself to understand what's happening. That's the first section basically, but then the rest of the section basically explains the layout behavior of all the individual, not all, but most of all most of the individual views that you'll use in SwiftUI, because you need to know, like, what does a certain view, like a text, what does it do with the size it gets proposed? What does it propose to its children? Well, text doesn't have children, but other views have. And then what does it do with the reported size of the children? And what does it report back? And each view has its own behavior that makes sense for what it's supposed to do. So we are going through all that. So these are all the leaf views, like text and colors and image and dividers and stuff like that. Then we have all the view modifiers like padding and the frames, especially flexible frames are quite complex. And yeah, and again, we go through these trees and with all the layout steps, aspect ratio. And then after view modifiers, we have, let me scroll down a little bit. At some point, we have container views. So we describe the H stack or V stack. It's the same thing in the end. Layout algorithm in detail. So how does the H stack actually distribute the space between its children or subviews? And other containers like Z-stack, scroll views, talk a bit about geometry reader in here, but that will also come back later on in a later chapter about advanced layout techniques. The lazy stacks, a bit of the lazy grids. And yeah, so that's basically the first section that goes through all these views. And I think it's, you can definitely just read it like a normal chapter. You can also use it as a reference. You can look these individual views up in here and see what they do. And then the second part of the chapter is about alignment. And alignment is also this tool that I think it's quite powerful because it does much more than just, I don't know, align the two top leading corners. The mechanism behind allows you to do much more with it. And so that's what we describe in the second part, is how alignment actually works, because alignment really always is a negotiation basically between two views, right? It's always like asking some view, okay, what's your bottom, what's your top, what's your leading? And then you can modify what the answer of that is basically, and you can build up quite nice behaviors with that. So we go over that, and yeah, that's basically the second part of the chapter. And yeah, that's I don't know, Chris, do you have something to add?
Yeah, it's interesting that you call this the most boring chapter. This is absolutely by far my favorite chapter. maybe, well, I guess we're complementary in that sense. Um,
Yeah.
I think, yeah, maybe, yeah. So it is a little bit repetitive in the sense that, we explain the layout behavior of each view and view modifier, but in the end, they're all so different that I don't think it's actually that repetitive after all. And there are definitely more obscure modifiers that we don't discuss, but I think the ones that we do discuss, most of them, you will probably people use them all the time. So
Yes.
I think it should be very interesting. And
Yeah.
I think this is also the chapter where it's mentioned in the chat that the diagrams are very helpful. This is, I think, a chapter where they shine the most, and also sort of on a meta level, I think I'm most proud of what we did there with the diagrams and the visual explanations in addition to the text. And yeah, I think like it's kind of weird, this layout system in the end to me. I love the SwiftUI layout system, and I think like 95% of the time I know exactly how to solve something because we dove into this so much. And then 5% of the time it's like you'll be thinking like, how would I solve this and what can I do? And is there like a clean built-in way, or do I have to use like geometry readers and all of that? And I think that
I think it's just the happy path is super convenient, right, and fast, and a lot of things just work like you'd expect, and that you just use stacks, v stacks, and h stacks, and z stacks, and you compose everything. But I think it's also the case that it can be super opaque. Like as soon as you want to do anything that is not like obvious, it can be super opaque of what's going on and how you bend this thing to your will.
Yeah, and I think just understanding the basics, and especially now with the new layout protocol, we can actually debug things and see how things work if we want to. So I think that's extremely helpful there. When we do these workshops, I think we often get this question, right, where people are like, "Hey, but how does this translate into layout constraints? Because there is auto layout under the hood, right? And then there is no auto layout. Like this is it. This is the whole layout system, and there's no need for constraints. And I think that definitely takes quite some time to appreciate and to learn. But to me, like I've done layout with CSS and UI kit with manual frames with auto layout, and I think this is to me the simplest system I've worked with, and it definitely has its downsides, and there's definitely things that are much harder. But like most of the things that you want to do are pretty easy, or very easy actually. And then it's like a nice flat floor, and then you do have that brick wall occasionally. But yeah. I don't know if there's anybody in the chat who has like layout problems. Feel free to ask questions here as well. There's a lot of hellos, which is nice.
So let me see, maybe we can, with the chapter out of the way, maybe we can take a look at, we just have 2 questions in the GitHub, but we can take a look at them. And well, let me see, just share this quickly here. And it should be this one here. So maybe let's go to this one first, because that's, I think, kind of a quick one. Because here it mentions that we have a picker somewhere, picker control, and then we do tags on the subviews, basically. And I think, I'm not really sure how to pronounce this name. That doesn't really matter. So I think it's probably correct that we could get rid of the tags if you have a for each or something like that, and we loop over something, and the selection is a string, and we have a string, and so what we are looping over is a string, we probably could get rid of the tags. That's actually a good point. We can keep this issue open and take a look at that in our book. See if we can simplify that, because sometimes this just works automatically for you if the types match. So that's a good point. We can take a look at that.
I think for each probably uses the ID, right? And as long as you have that, then you should be good. But I don't remember exactly. And maybe the next question is, we got this sent in via email from Daniel about, so he thought like, okay, when we have like a group of views, like multiple views, and then we apply a border, it adjusts the environment and then sets the border for each of the views. So it's kind of like as if every view had like this border property, similar to how things were maybe in UIKit. And
let me show that in code quickly what we mean, perhaps. I just have opened a standard iOS SwiftUI project here, and so basically the thing is that what happens if we have something like that, right? We could make this group, and then we could set a border here and say, I don't know, color the blue, and we zoom in a little. Okay, and we can see here that both views have the border, right? The image and the text have the border. And so you could imagine that calling .border is setting some sort of environment value that we want to have a border that this propagates down the tree. And each of these views, like image, or this case, there's a few modifiers on top, but essentially the image and the text kind of take care of this border. They read this from the environment and do that. But you can really see that it's not that if you change, for example, the group to a VStack, because then the border changes. So if that would be propagating to the environment, it should still be propagating to the text and the image view. And the borders around these individual views should still be drawn. But that's not the case. And I think we can even, let me see if that works here. Can we go through to the definition of border?
No, but
no.
I can try to show it.
Do you have that here? Yeah.
Yeah, give me 1 sec so I could set up here. So let's see, portion of screen. Okay, so what you can do is you can go to, let me try this again. Yeah, you can go to xcode.app, and then here you can do a find command, and you can find all the Swift interface files. And then one of them will be SwiftUI.Swift interface. And we can try to open that. And let's see, the Swift interface. And then we can use maybe Nequin. And let me pull this up here. Okay, so this is the Swift interface. And if you really want to understand how things work, this is super interesting. Like, it's a massive thing. But if we search for func border, we can actually see the implementation. So this is an extension of view. So this is the actual border. And there's the implementation. So what a border does is it does an overlay with a rectangle, and that rectangle has a stroke border. And that's really all there is to it. A border is nothing else. It's literally a rectangle overlaid on top. And now if we go back to Xcode, so I think the key thing here is that in SwiftUI, when we write a view builder, we always describe a list of views. And so if we have a nested view and we have a body, we can actually put multiple views in there. and the nested body could return sort of a list of 2 views. And now if we say nested dot border, what's happening is that, let's see, line width. Maybe like this. Okay. So let's see if the content view also resumes. Not very lucky with Xcode yet. Maybe I'll run it in a simulator.
Yeah, I think it's a preview thing.
So this is kind of interesting. Here, we can see that it displays the border around both views. And I think we have seen both of these behaviors where it sort of puts it around each individual or around both views.
And that is actually, so what we saw here, that it is behaving like one single border around both. It's really a special case in this here, because we have this as the root view, and then things in the root view get basically
Yes.
a list of views as a root view becomes an implicit VStack. And there are a few things like that. If I recall correctly, scroll views do that as well. And something like overlays or something like that, I think they turn a list of views into an implicit Z stack. So there are a few cases like that where a list of views suddenly appears like one monolithic view.
So what happens if we put a VStack around this?
Exactly. I think that should make a difference. We'll test that.
See if we can get the previews to work. I don't think they're going to work. I'll launch the app.
Just launch it. Yeah.
So now we can see that what's happening is we have a VStack as a root view, and then inside we have actually a border view, and that has a group of children. It has 2 children. So it's not a single, I mean, the view is nested, but if you expand the body of that, it's 2 children. So the border gets applied to each of these views, which is, like first I thought, when I saw this is a bug, but then this is actually how, well, whether or not the border should behave like that, I don't know. But the fact that you can return multiple views is, I think, inherent in the design of SwiftUI. So you can actually use this to your advantage, and you can do something like this. So you could say toggle equals false, and then you could say if toggle, we do a VStack, else we do an HStack with nested. And now we can add a toggle as well, maybe a VStack around the entire thing, and say toggle, toggle, toggle. Maybe with text. And so if we run this, we can see that we can switch between an HStack and a VStack, and both get these 2 children in. It's a little bit of an obscure use of SwiftUI, and I doubt, like in a larger company, that people will like this in code review. But yeah,
but I think it's really good to get a grasp on that, because in the end, as you say, it's really fundamental to how SwiftUI views are composed, right? A view builder returns a list of views, and a body property is an implicit view builder as well. So it returns a list of views, and the case that it just returns one view is a special case. You can just think of it as a list of one, basically. But each view builder, so a body where you write multiple views at the root level, or if you write a property in your view that you mark with @viewBuilder, or the closure after an HStack or something like that, all these view builders will produce lists of views. And if you apply a modifier like border or like any other modifier, really, it will get applied to each of the views. And if you put a list of views like that, you can even have a nested list of views, right? And it will, if you put all of that in an HStack, it will be flattened out to one flat list of views to the container. So to each H stack or V stack, for example. Exactly.
Yeah. So here we have 4 views, and if we maybe set the spacing to 0, you can see that there's really nothing in between, or maybe it's even clearer when we set the spacing to 50. And each of these has exactly the same spacing. And this can go as deep as you need to. Yeah. And can have if conditions as well and all of that. Basically, and the weird thing is, if you look at the definition of VStack, if we go into that, we can see that the content, the parameter of content, conforms to view. So in a way, this is a little bit of a that when you have something of type view, like they could have called it views or view list or whatever. But I mean, I'm glad they called it view. It's fine, but it's also a little bit confusing. And maybe just to go into this in the chat, Sean is asking about varietics. So this is varietics is this technique where you can actually loop over the views that you get. This is not public API, but it's semi-public. And so you can, I don't know if I have a snippet here, you can actually loop over the list of views and do stuff with that. So I don't have a snippet available, but this is something you can use. Like if you build your own components, you can loop over all the views that get passed in and filter out certain views or do other stuff with that. You can do a little bit of that with the layout protocol, but there you don't really get to filter out views or like leave them out and not draw them. The variadic views is definitely. Sorry, what was that?
Or insert new ones. You cannot do this either in the layout.
Yes, yes. And I think that the go-to place for variadic views is moving parts. So let's see, they have a blog. Here we go. So this is the blog post to read on that. We have a very simple way we use this, but they show all kinds of things you can do with variadic views. Like this, for example, writing a divided container is not so easy to do without variadic views, or maybe impossible.
Yeah.
And there's another question in the chat. Are the problems from the first edition appropriate to use while reading a new one? So in the first edition, we actually had exercises in the book. We left those out for now. And yeah, I haven't looked at the actual exercises yet. As we mentioned a few times before in the previous Q&As, we completely rewrote the book from scratch. So we didn't really reuse anything. And so I don't have the exercises in my mind, but I think, at least at the time, we tried to design them so that, they are very useful. But I think you should be good doing those exercises.
Yes. So there might be simpler ways of solving them, like what we suggested back then. But even then, it's still a useful exercise probably to just do them in the way that they were designed back then. Yeah.
So maybe one thing we can still show, let me share my screen again here, is we talked about these layout trees and how views propose to other views and so on. And you can actually debug this. So let's say we want to see how an H stack works and how it proposes. Like, for example, the behavior here is very interesting. If we say text hello, and then a rectangle with frame height 20, or maybe let's do a color that's teal. So if we run this, we can see that hello and the color fill up the screen exactly. So you have to believe me, but the right border of the teal color is exactly the right edge of the screen. And if we swap these two around, it's the same thing. So we can see now the teal gets the full width, basically minus the width that's needed for hello. And the way HTAG works is it sort of asks, the first thing it does, it asks these children for their flexibility. So it asks like, hello, how flexible are you? Like, what's your minimum and maximum width? And the difference of those two values is the flexibility. And then it does the same for the teal color. Because a color can become any width you propose, it's super flexible. So what the HTAG then does is it first proposes half of the remaining width to the text, and then the other half to the teal color, or actually not the other half, the entire remainder. And we can see this. So let's set it to spacing 0, just so that we get even nicer values. Okay, and if we want to debug this, we can sort of do a little trick where we create a debug layout. So we can use the layout protocol for this. And this needs two methods that we need to implement. So the first thing is that for place, we can just take the first subview and place it at bounds.origin and pass on the proposal. And here we can log the proposed view size and say proposal. And to make the logging a little bit clearer, we'll include a name here. And you can say proposal name. And now, of course, we also need to return subviews 0 size that fits proposal. And let's just assert we have only one subview. And the other thing we can do is now we can write an extension on view and say log proposal name string and return some view. And we'll just use our debug layout with the name we get passed in and use self as the only view inside the debug layout. And now we can do a log proposal here. So this would be the teal frame. And we can log a proposal here. So this would be the text. And if we run this, it's a little bit hard to parse, but we can see first it proposes to the text 0 and a width. Then it proposes infinity, 0 and a height. Then it proposes infinity and a height. So the thing to watch out for is the width dimension. So it proposes 0 and infinity and 0 and infinity for the teal color. And then because our text is less flexible, it starts by proposing to the text, even though that's the second element in our HTAG. If we swap the order around, see, it should still, first it figures out the flexibility, that's what we can see here, and it still proposes to the text first because that's the least flexible value. We can actually even do something like this and say let result equals, return result, print actual, and include the result here and the name. Now we can also see this. So we can see the color. If we propose 0, it is 0. If we propose infinity, it is infinity. And for the text, if we propose 0, it's 0 for the width. And if we propose infinity here, it's actually only 39. So the flexibility of the text is 39 minus 0. The flexibility of the teal color is infinite. And that's why it proposes to the text first.
That's actually a very, since we have the layout protocol, that is a very handy way of actually getting some insight into what's going on, like how SwiftUI proposes and reports. And another thing you can do that is even simpler is to use shapes. So if you don't want to apply some logging to arbitrary views, you can also use shapes, because in the shape protocol that's exposed as a public API, the size that fits method, and you can use that to actually log what's going on there. And then as long as you just plug in shapes into your stacks or whatever you want to inspect, that works as well.
Yeah, and these are sort of more advanced, I would say more advanced techniques to understand the layout behavior. In many cases, you're just interested in the size of a view. You're not really interested in what it got proposed and everything. And there, what we often use is also an overlay with a geometry reader, and then we sort of use the proxy that size, put that in a text view, and then you can always see the size of the view. And even more low level than that, or sort of not low level, even simpler than that, is just a border. Just putting borders around the view, because a border, as we just saw, is made with an overlay, and overlays have this special property where the secondary subview becomes exactly the size of the primary view. So the border will always be exactly as large as the view. So that's very useful for debugging. I think that's what we use the most.
All the time. Yeah. Okay. So I think that's all the questions we have for today. If there are no other ones in the chat, let's see. There's still Boron Krypton mentioned, if you add a background button to a VStack, you get multiple buttons for each element, if I remember correctly. And I think that should not be the case. So if you add a background to a VStack, the background is really applied once to the entire VStack. It's not something that will be applied to each view individually. So if you would pull out, let's say, the contents of the VStack into a separate view builder property, and then you apply the background to this, then you're applying the background to a list of views, and then each of the views will get the background. If you put it onto the VStack, then the VStack will only get the background once. That's the subtle difference there.
Yeah, one interesting thing, Florian, that you showed, maybe we can quickly share that, and then we can probably make this a short one today. Let me share my screen again here. So what you showed is that if we put multiple views inside our content view, so not just a single view, what happens is we have this automatic VStack that is put around it. And it's the same thing if we use a scroll view. It sort of implicitly puts a VStack around things. So we can see that here, and we can scroll. What's interesting is, I think, so VStack seems to be the default for most of these things. If we do something like, let's say, color that gray and then an overlay and have multiple views in that overlay, those get put into an implicit Z stack. So here it's a little bit hard to see. Let me swap those two around. And this is actually in the documentation, I think. So if we scroll here, yeah. If you specify more than one view in the content closure, it collects all the views into an implicit Z stack. And so yeah, that's kind of interesting. And it's the same with backgrounds. If we set this to opacity 0.2, we can see that they also get put inside the Z stack. And this is the implicit behavior. Like if you just want to be sure, or if you don't want to be dependent on the implicit behavior, just put a VStack around it and you're good, or an HStack or whatever you need.
Yeah, and if you think about it, SwiftUI has to do something like that, right? What is a background with a list of views? You have to decide somehow how you're going to arrange them. So that's what's happening here in the background with the implicit Z stack, or then in the scroll view with an implicit V stack, things like that.
Yes. And, there's one more question in the chat. So the question is, can we elaborate on when we should use size that fits? Is it for more advanced layouts?
View that fits.
Yeah, but probably view that fits.
So I think view that fits. I'm not sure if that's what you mean, Lyra. Do you mean this view that fits that we got last year or something like that, where you can put multiple views in there and SwiftUI will choose the one that fits?
Yes,
because that's basically a handy abstraction around something that you could do yourself before, right? With measuring stuff with geometry readers and stuff like that. And that's really, I think that's really something where you might have two different versions of, I don't know, some sort of a profile view or something like that, right? Maybe one that has more information, one that has less information, and you might want to pick the one that actually still fits on screen or with the current font sizes, something like that. I think that's really the intended purpose of this kind of view.
Yeah, so this, let's see, hello test longer world. Let's run this again. So view that fits, and let's see if it launches. You get multiple views in, right? And then let's say we change the dynamic type. So this fits. So it always displays the first view that fits. And if we enable dynamic type, we can see that like here it still fits, and at some point it doesn't fit anymore, and then it switches to the second view, and it will do so on and on until all the views are gone. So there's like here it doesn't really matter whether hello will fit or not. It will always fall back to hello, and you can have multiple things in here. So you could say like a rectangle, whatever you want. And I think it's especially useful if you're designing for different screen sizes combined with dynamic type, right? Like you might want to have like a view that you display in landscape, but then if it doesn't fit in portrait because somebody's on a smaller iPhone or has like a large font size, that's how you could do that. And
yeah, you could think of something like I don't know, you have like a news reader and you want to have some sort of a detailed article details or something with the date and the author and the last change and whatever tags, whatever, and then you could have different versions of this view that show different kind of amounts of content, or maybe once you have written out labels and the other view only has symbols to make it shorter, something like that. And then you can, it's a little bit of an attempt, I think, of making this easier to produce like quasi responsive layouts.
yes. So here's one thing. So if we put a border around this, we can see that this view that fits becomes exactly as large as the first view. And if I now increase the font size here, we can see that it gets smaller. And this is why I think, I don't think we could have implemented this ourselves before. If you want to know whether a view fits, you have to sort of know what was proposed. And the only way to know this before iOS 16 was using a geometry reader. And the geometry reader always becomes the full width of the screen, regardless of what you do. So I think view that fits seems to be like a fundamental new addition that they added in iOS 16 that wasn't even possible before. And in most cases, or in most contexts, you could do something with geometry reader, and it doesn't matter. But it's still, I think, it seems to be pretty fundamental, from my understanding.
Yeah, that's a good point. That's true, because otherwise, to figure out if something fits, you need to know what are the boundaries of the thing it should fit in, right? And then you already have a view that expands to the full size.
Yes.
Good point.
Yeah.
Okay.
So next week, I think we're going to do the environment. That's the next chapter. It's a little shorter. Yep. So if anybody has any questions about the environment, please send them in by next week. Send us a tweet or a Mastodon or on GitHub issues, like a video message somewhere. And yeah, I think that's it for today, right? Do you have anything to add?
Sounds good. No, I think that's it. So
okay.
Then I would say let's come back next week and talk about the environment.
Yeah, thanks for joining, everybody.
Yeah.
Have a great weekend, and see you all next week.
See you around. Bye-bye.